This is the lecture for Section 4C about savings plans and investments. In the previous lecture, we talked about depositing a set of money and just letting it sit and figuring out how much would be in the account. Well, today we're going to look at what happens if you make repeated regular payments into an account. How does that money grow? So you'll see here, this is a pretty large formula. I'm going to show it to you once, and then I will, just like last time, show you a website that will help us calculate this a lot easier than by hand. But our variables, again, A for the amount, P is going to be a repeated payment. We have our APR, which is still our annual percentage rate. N is the number of payment periods per year, and then Y is our number of years. We want to use the saving plan formula to calculate the balance after 6 months for an APR of 12% if we have monthly payments of $100. First, I'm going to show you a table that outlines how this works, and then we will go to the formula. So let's take a look at the table here. In the first month, you're going to deposit your $100. And then here is your balance at the end of the month, $100. In month 2, you will earn interest on that $100 that is sitting in the bank. So we had 12% APR. So if we're depositing monthly, divide by 12, it's going to be 1% every month. So $100 times our 1% means I'm going to earn $1 in interest. But I'm also going to then deposit another $100 into the account. So I'm going to add all of these values together. 100 plus 1 plus 100. My new balance is now 201. The end balance for month 2 is 201. That's going to be used to calculate the interest in the next month. So we'll take 201 times our 1% interest for the month. We're going to get $2.01 this month. But we're also going to deposit another $100. So adding these all together, we now have a balance of $303.01. We will earn 1% interest on that $303.01, and that will be $3.03. We're going to deposit another $100, add these values together to get our $406.04 at the end of month 4. Repeat it again, take that balance times by our 1% interest for the month. Going to get $4.06 of interest in month 5. We're going to deposit another $100, add these values together. We are now at $510.10. And then 6 months, we are going to take that 5, 10, 10. We're going to get our 1% interest for the month, which is $5.10. We're also going to deposit another $100, add these values together. So at the end of 6 months, I'm going to have a total of $615.20. We can use the formula knowing that our payment is $100, knowing that our annual percentage rate is 12%, so 0.12. We're going to deposit monthly, so N is 12. And then up here, we make deposits monthly, but we're going to only do this for half of a year. So our power up here ends up being 6. And we talked about how we can type these into our scientific calculator. You could type this whole thing as it is in a scientific calculator. You could simplify it a little bit down here and do the 1 plus 0.012 over 12 and get 1.01. And you could take this 0.12 over 12 and make it 0.01, and you could simplify it a little bit before you type it in your scientific calculator. But you should get $615.20. So I want you to at least try it one time here in just a scientific calculator to make sure that you do get that answer. And then I am also going to show you how we do this in a calculator that will do the work for us. Okay, so I'm going to show you first how we would type this into Desmos if I was doing the work by hand.
100.
And then you do 2 sets of parentheses. 1 plus 0.12 over 12 close that pair of parentheses, raise it to the, in parentheses, 12 times a half power, and then arrow out -1. I'm going to then close that set of parentheses, divide that all by, in parentheses, 0.12 over 12. And you see I get that same answer of 615.20. Now, like I said, the formula is a little messy. So what we're going to do is we have a calculator here that we can use. And the note here is it says, your interest rate must be entered as the decimal form divided by the number of compounded periods in the year. So we're going to take R divided by N. We're going to actually type it in that way in this calculator. And then N, the number of payments, this guy here, must be entered as N times T, or N times Y. So we want to solve for our future value. The R here is the amount of your recurring payment. So R, think of recurring deposit, which is $100. I stands for the interest rate, which is 0.12, but we're going to pay this 12. We're going to do this 12 times. I'm going to put a deposit down every month. And then N is 6 months. So I'm going to do that 6. And we get that same answer of 615.20 that we got with the formula. So let's try 2 more here. Find the balance in the account after 5 years with an APR of 4% and a monthly payment of $200. So a few things we have to remember here. So our recurring payment is $200. Our interest is 4%. We're going to do monthly, so 0.04 over 12. And then the number of times we're going to do that, well, it's 12 times a year times 5 years. So I need to make sure that when I go here to my calculator, I do all of those values as is. So 200 interest rate. We got 0.04 over 12. And then this is going to be 12 times 5, which is 60. And then down here is going to be my final balance after those 5 years. So I will have $13,259.80. Next one, at age 25, you set up a retirement fund with an APR of 5%. At the end of each month, you will deposit $150 in the account. How much will be in the account when you retire at age 65? And then how does this value compare to just the money you deposited? Well, so our recurring deposit is $150. We're going to do this every month. So the rate has to be 5%, 0.05 divided by 12. And then our N, 12 times a year, we're going to go from age 25 to 65. So that's 40 years that we're going to do that. So again, I'm in this solve for future value here because it says find the future value. So notice here that there is more than one calculator. We are just using solve for future value right now. 150. 0.05 over 12, and this is 12 times 40. So this one gives me $228,903.02. 28,903.02 will be the money in my retirement account when I am age 65. So the question says, though, then the second part, how does this value compare to just the money you deposited? Well, let's look at that for a minute. I'm going to go down to the bottom here, go into an empty box here. We deposit $150 12 times a year times 12 for a total of 40 years. The amount of money that you put into the account is $72,000. So our deposit total is $72,000. And if we compare that to 228, let's see if I do some division. I want to say it's about 3 times as much. 228, 903.02 divide by 72,000. Yep, it's just a little more than 3 times the amount that I've just earned in interest. By doing that repeated payment, you are earning so much more interest, and it's a great tool to use to plan for your future and your retirement. You would like to retire 25 years from now and have a retirement fund from which you can draw an income of $50,000 per year forever. How could you do that, assuming we have a constant APR of 7%? So, what this question is asking is we want to have some amount in our account that if I pull out $50,000 during that year, I will earn back that $50,000 in interest. Well, if we know that we have $50,000 and our APR is 7%, our total balance would have to equal 50,000 divided by 7% or 0.07. And that gives me $714,286. What that means is if we have that 714,286, or if you just want to round it up to $715,000, what's going to happen is you can withdraw that $50 from that account, and you will never reduce that principal. It will go back to $715,000. So if you take out $50,000 at the beginning of the year, interest will pound it back up, get you back up to that $715,000 for the next year so that you can do that again. Well, if that's the amount you need, we could then work backwards to figure out how much I would need to deposit now monthly to be able to have that value. So we're going to assume we want to accumulate a balance of $715,000 by making regularly monthly deposits into that savings plan. We have our annual percentage rate of 0.07. We're going to do this monthly, so N is 12, and we're going to do this for 25 years. What we're asking for now is the payment that would give us this amount. What we can do then is rearrange that initial formula we had for amount equals payment times the fraction and solve it for payment. And it gives us this fraction, messy formula fraction here. So we can plug in what we know, 715,000 times APR 0.07 over N, and then 1 plus 0.07 over N, 12 times, it should say 25. I will fix that typo because it's 25 years, 12 times a year, minus 1. And then again, I could go to that scientific calculator, type it in up here. I could simplify some of these values, type it in like this, but I would get $882.64. So what that would mean is roughly if I deposit $883 per month for the next 25 years, I would reach that balance of $715,000, which I could withdraw $50,000 every year and still have $715,000 at the end to be able to do that again the following year. I'll first show you how we could type this formula in to Desmos Scientific Calculator. 715,000. I've got the times 0.07 all over 12. And then what I want to do is I want this to be the top of my fraction. So if I highlight it and then hit the divide button, it'll make the fraction there. Couple parentheses, 0.07 over 12 raised to the 12 times, that's again, say 25. 12 Nope. Okay, I have to make sure that's in parentheses. 12 times 25, and then put the minus 1, and I get that same answer of 882.64. But as I know, this is a really messy formula, and most of you are probably not in this class wanting to have to do all of this hand calculation. So that leads us to that Desmos calculator again. That same future value calculator that we used a little bit ago. Remembering again, interest has to be listed as the rate divided by the number of times we're compounding, and n is going to be that number of times t. Now, we were using future value. I don't want that anymore. I want to solve for the payments. What I'm going to do is I'm going to open up this calculator here. And then the S here is the amount I want to have, the sum value that I want. 715,000. I'm going to take my interest rate, 0.07 over 12. And then this was 12 times 25. And then the value comes out, same value again, 882.64. All right, so let's try these two here. Again, finding the payment. So just make sure those are the only two we're going to use in this calculator here. You're either going to be asked for find the future value or balance in the account, or finding the payment value. Your goal is to create a college fund for your child. Suppose you find a fund offering 5% APR. How much should you deposit monthly to have $170,000 in 15 years? Okay, so we want to have $170,000. So this is the sum in the account. The rate that we want is 5%, but we're going to have to do it monthly. So we're going to divide by 12. We're going to deposit 12 times a year for 15 years. So 0.05 over 12. And this is going to be 12 times 50. And it is saying here, I would need, down here, this guy, R, that value, $636.02. So 636.02 is the answer we want. So that is under the R, the recurring deposit. And then last example here, at age 20, when you graduate, you start saving for retirement. If your investment plan pays an APR of 4.5%, and you want to have $2.5 million when you retire in 45 years, how much should you deposit monthly? So a few things we need to know. How do we write $2.5 million? Well, 2,500,000 is $2.5 million. And that's the sum that we want to have. Our rate is 0.045 divided by 12. And we're going to do 12 times a year for 45 years. So we'll go here. 2,500,000. Interest rate is 0.045 over 12. And we're doing 12 times 45. And right down here is our recurring monthly balance payment is $1,431.85. Another thing we can discuss is called total return. If we consider an investment that grows from an original principal P to a later accumulated balance A, the total return is the percent change in the investment value. So we will take our ending balance minus the initial balance divided by the initial times it by 100. This is usually going to occur over multiple years. Considering that same investment that we had started at some value P, grows to some balance A so many years later, we can actually go back and determine how much it changed per year, or what would be called the annual return. We could take the amount at the end over the principal or the starting value, raised to the 1 over however many years we had the account, and then subtract 1. If you invest $3,000 in the Clearwater Mutual Fund, this is your initial investment, your P, over 4 years, your investment grows to a value of $8,400. That's for A. What are your total and annual returns for that 4-year period? So total return, we take A minus P over P times 100%. So A, 8,400 minus P, 3,000 all over 3,000 times 100 is going to give me 180%. Annual return takes the amount at the end, 8,400, divided by the initial amount, 3,000, raises it to the 1 over y. Well, we have the account for 4 years, so it's going to be 1 over 4, and then minus 1. And I would usually just enter this right here into my scientific calculator, and it's going to give you the decimal, 0.294, which you got to times by 100 to get your percent. So what it's saying is about every year it's increasing by about 29%. Let's look at 2 more examples. 3 years after paying $3,500, there's your initial, for shares in a company, you sell them for $2,000 at a loss. There's your A. What is the total and annual loss? Well, total takes A minus P, so 2,000 minus 3,500 divided by the initial of 3,500. So we can go over here, 2,000 minus 3,500. I get negative 1,500. And I want to divide that by 3,500. And I then need to multiply that by 100 to make sure it's a percent. So the total loss that I experienced was just about 43%. So about negative 43% total. Now, if I want to do annual, I'm going to take that A value, 2,000 over the P value, raise it to the 1 over, let's see, we had this for 3 years, so 3, and then minus 1. So open parentheses, 2,000 over 3,500. And raise that to the 1 over 3 power. I'm going to put it in parentheses just so that it is all together. Minus 1. Oops. Minus 1. And then I'm going to take that value and I want to take it times 100. So negative 0.17. If I times it by 100, it's 17%. So I lost about 17% every year. So about 43% in total, about 17% per year. So about negative 17% per year. Next example, 20 years after purchasing shares in a mutual fund for $6,500, there's your P. You sell them for $11,300, there's your A. So again, I'll write my formulas here and then we can go to our calculator. So my 11,300 minus 6,500 over 6,500. Let's see what we get. So 11,300 minus 6,500. I think that 4,800 over 6,500, and I got to remember to times that by 100. So cost about 74%. I'm going to put that times 100 in there. Times 100 is about, I said, 74% total. that my increase was. And then annual is going to take that 11,300 over 6,500 to the 1 over, we now had this for 20 years. Put it over 20 and then minus 1. So in parentheses, 11,300 over 6,500, close, raised to the open parentheses 1 over 20, arrow out, minus, minus 1. So if I take that value, 0.028 times 100, gives me 2.8% or just about 3% increase per year. Other ways that you can invest are with cash investments, such as money that you just put into an account, certificates of deposits, or called CDs, or U.S. Treasury bills. Another type of investment is a bond or a debt, which represents a promise of future cash. What happens is you can buy a bond paying some principal amount to the issuing government or corporation or bank. And basically that person will pay you the interest over time, and they promise that they will pay you back that initial investment and the interest at some later date. And the third investment we're going to talk about here is called stocks or equities. And that's where you own shares in a company and you can invest some money to purchase stocks. The only way that you get money out is if you sell those stocks, and you have to watch the prices of those stocks. You want to sell when the price is higher than what you bought it for, so that you make sure you gain versus lose on your investment. Other things to consider is how liquid that money is. Is it easy to get that money out? If it's just in a savings account or checking account, that's very easy to get. That is liquid money. If you have it into a bond, it is not liquid. You have to wait a certain amount of time before you get that money. You're going to want to look at your risk. What is your risk involved in if you are getting maybe stocks? Is this a solid company, or are you investing in a up and coming company? And that may yield more results, but it also can lose more money as well. And then your return, how much you can expect to gain back on your investment. The lower the risk, the lower the return. The higher the risk, you could have really high returns, but you could also have really high losses.